Hi everyone. So in this video I will be teaching you about Bayesian statistics. By the end of this video I will assure you that you will not be needed to watch any video or be forced to memorize the formula. Before going into Bayesian theorem, let's first understand what is P of A given B. Let us take an example so that you can derive the formula by yourself. Let's say P of A is probability of getting a tail when B is given. That means you have already gotten a tail. Basically, you have done two coin tosses, and in the first coin toss, you got a tail. What is the probability that you'll get a tail in the second coin toss? By common sense, this event is not dependent on this event. That means, even if you got your heads or tails, doesn't matter. The chances of getting tails here in the second coin toss is still 50%, right? Now, there is another way of looking at it. What is the probability of getting two continuous tails? Well, it is probability of getting one tail into probability of getting another tail. Because these two events are independent, I can simply multiply them, which brings me 1 by 4. Right? So the probability of getting two tails is 1 by 4. Now, in the numerator, I write 1 by 4. But in this 1 by 4, I am also including the probability of the first tail. But it is already given that I have gotten a tail in the first coin toss. That means I have to compensate for this. So I will divide by the probability of B. Essentially what I have done here is I have written probability of getting both the events together, which is probability of A intersection B, which means probability of A and B occurring together, divide by I am correcting it or I am normalizing it by probability of B. Why am I normalizing it? Because B is already given. It is given. It is already being said that my first coin toss results in a tail. So the probability of A given B becomes this formula. Let us take another example to understand it better. What is the probability of raining today given that it rained yesterday? Well, first we will calculate the probability of raining on two consecutive days, but it is already given that it has rained the previous day. So I will divide it by B. It is that simple. Now you know probability of A given B is probability of A intersection B divided by probability of B. This is just for normalizing. If I change A and B, then obviously instead of A I will need to write B, and for B I will write A, and this will be the formula. This and this is essentially the same. I mean, by common sense it is the same. A and B or B and A is the same. So what if I try to divide these two equations? Let's see what happens. Probability of A given B divided by probability of B given A. I will get probability of A divided by probability of B. Now probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Just look, you have got the Bayesian formula and you did not need to memorize anything. If you want to break down this further, what you can do is instead of B given A, just apply the formula of B intersection A divided by probability of A, and you will see A getting cancelled, and you will finally get probability of A given B is equal to probability of B intersection A divided by probability of B, which is the formula that we have started with. See, you have derived the Bayesian formula by yourself. But what does this Bayesian formula even say? Let me show you this by an example so that you understand intuitively and not just by the mathematical formula. If you incorporate the mathematical formula in your understanding, then everything becomes common sense. You will not need to memorize this formula. Let me give you an example. I need to find probability of me getting fever given that I have suffered with cold. To calculate this, Bayesian theorem says what is the probability of me getting cold given what is the probability of getting cold given someone had fever into probability of getting fever divided by probability of getting cold. What is the probability that someone will get fever given that someone has cold? First, we'll calculate what is the probability of getting cold given that someone had fever. Out of 100 people has fever, but only 5 of them has cold. Then, obviously, by if you think about it, out of 100 people having fever, only 5 people have cold. So the probability of this will be less, right? That is what this term means. It is basically called as likelihood. What is the likelihood of someone getting fever given that they have cold? Now, coming to the next term, what is the probability in general of people getting fever? Let's say there are 100 people in my city and let's say only 2 of them get fever. If this number is less, then obviously this will be less. Now, this is called the prior probability. That means in, in general, whether I have cold or not, the percentage of people getting fever is less, is only 2%. That is why this is called as prior probability. If you, let's say you don't know probability, how will you calculate probability of getting fever? Well, you will say that in my town, the percentage is very less. I mean, not very people get fever. So that's why I will simply say that probability of me getting fever divided by given probability of me getting fever given I have cold will be just 2% because probability of fever is less. Well, here you are missing given cold. Here you are assuming that probability of me having fever given that I have cold is 2%, which is wrong. That's why this is called as prior probability. Now this probability will correct it by other factors. The first one will be likelihood, as I have explained it to you, and the denominator one is the evidence. That means what is the evidence of people getting cold irrespective of they getting fever or not. Let me give you an example so that you can understand better. Let's say probability of having fever in my town is, let's say, 2%. Probability of people getting cold is, let's say, 1%. Probability of someone having cold given that they have fever is, let's say, 10%. Okay. Now simply tell me, if I have cold, what is the probability of me getting fever? Just use common sense, don't use any formula. Well, you will say that, okay, so the probability of people having fever irrespective of cold or not is 2%, which is less. So I'm assuming this number will be less. But probability of having cold is even lesser. So wait, the probability of having cold is lesser and I have got cold, which means I am in those rare 1%, which means my chances of fever will increase. If probability of cold decreases and I have gotten the cold, so probability of fever given cold will increase, right? And if probability of fever decreases, probability of fever given cold will also decrease. Perfect. Now, probability of people having cold given that they have fever. If this is more, that means when people have fever, it is observed that 10% of them have cold also. And if this number increases, let's say this goes to 50%, that means if 10 people have fever, 5 people have cold. That means if this increases, so does this. Now simply by using common sense, you can figure the formula out yourself. If this has to increase, then if this increases, this will increase. That's why this will be in the numerator. Make sense? Now, if this decreases, this also decreases. That means this also has to be in numerator. Why? Because they go hand in hand. If this decreases, this will decrease because it is multiplied, it is in numerator. This increases, this will increase, this decreases, this will decrease, which makes sense. But these two are opposite. If this decreases, this increase. So if we keep this in denominator, then it will make sense. If probability of cold increases, probability of fever given cold will decrease. Now let us substitute in the formula and see what we get. This will be 10% into 2% divided by 1%. 10 by 100 into 2 by 100 divided by 1 by 100. This will be 20 by 100, which is 20%. If you start to generalize that probability of me getting fever given that I have cold, if you generalize this to just saying that what is the probability of having fever, let's say 2%, so this will be 2%. This will be wrong, right? This will be wrong because you are neglecting that I have cold. And what percentage of people have cold? It is only 1% of people having cold. If you incorporate all this, then the probability becomes 20%. Do you see how you have increased your accuracy? Before you were saying it was 2%, now it is 20%. This is how Bayesian theorem is used, and you know how to derive the formula. You know what is P of A given B. All that matters is you conceptually understand this. If you understand this, everything else is just a cakewalk. Think about different examples. Uh, Connect these formula to real life. Well, it is not that hard, it is all common sense. Once you try to establish this connection of probability with real life, everything will seem cakewalk and it will be very natural to you to derive these kind of formulas. That's it for today. If you understood it, please leave a like. If you did not understand this, no problem. Tell me in the comments below and I will try to explain it in a more simpler way in the coming videos. Thank you for your time. Bye.